Kia ora Year 12, here's another video going over some vector problems from old AES papers. So this time I've managed to use 3D Geogebra instead of bad drawing so that you can visualize exactly what's going on in each question. Obviously you can't use Geogebra in the exam, but it's a really good way if you're having trouble with vectors to get a picture in your head of what they're all about. So here's the question first. Hopefully you've watched the first video. This one is slightly different. Here we're given two position vectors. So the first one, A, is here, and the second position vector of B is 7i minus 3j plus k. We're going to whack those onto a graph in a minute. The first thing to do is to show that angle OAB is a right angle. And then we have to find the area of triangle OAB. So this part is going to be really easy. We're going to use half the base times the height. There are two ways to do this question. This one here, right? If we want to show that something is a right angle, think about what you first would have done before you knew anything about vectors. So hopefully the thing that comes to mind is Pythagoras, and that's one way that we can approach this problem. And the second way is to know that if we've got two vectors that are at right angles, then their dot product will equal 0. So I'm going to do this question in both of those different ways because they're both good ways. So this is what the vectors look like. And I just want to talk a bit about how GeoGebra displays things. So the red line, let's see if I can get the pen working. The red line is the x-axis. The green line is the y-axis. And the blue line is the z-axis. Now, there are different conventions about how you display vectors, and it doesn't matter too much, but this is probably the most common one. And when you're thinking about what the vectors look like, we've got vector A. So A is 3i plus 2j minus k. So remember that all that little I is a 1 unit step on the x-axis. J is 1 on the y-axis. So that little bit there is I. This little bit here is j, right? 1 unit in the y direction. And k is 1 unit in the vertical direction, the z direction. So what I've done here is I've found point A out here. So that's A. And then we've done the same thing for B. Right, what's B? B is 7i minus 3j plus k. So if you're looking at this and you like it, all you have to do is go to geogebra.org, which hopefully most of you have seen and done before. But then what you've got to select is the 3D calculator. If you're just starting out in A level, it's well worth making yourself an account because it really helps you visualize lots of the harder problems we're going to get to. So far I've put on A and B as points, and the other big point we can think about is the origin here. Right, so let's look at what the question wants us to do. It wants us to show that the angle OAB is a right angle. So now we're going to start to make some vectors and join some things up. Okay, so this is A and this is B. So we're now showing this here is the vector going from O to A, and this is the vector going from A to B. And we could do a dotted line back here. So what we've been asked to show is about angle OAB. Be really careful when you're working with problems like this. Always look at what is the center point, right? So we're not looking at anything, we're not looking at the angle between OA and OB, right? Because that's not going to work out to be a right angle. We're saying we want to show that this angle here in 3D is 90 degrees. So we have to find OA and we have to find AB. So we'll do that on a new screen. So OA we've already got. OA is 3 to -1. And we're not going to bother to do this very often, but it's the A point minus the first point, which is O. So of course that's just 3 to -1. You don't have to bother writing that step down, but just in case you're still finding vectors awful, it might help. So now we're looking at the vector from A to B. So our end point is 7, -3, 1, and our start point is 3 to -1. Giving us 4, -5, and 1 minus -1 gives us 2. So the fastest way to do the first part of the question is to take the scalar product and say that if OA dot AB equals 0, then the vectors are perpendicular. So I'll do it that way now. But that is going to leave us a little bit more work to do in the second part than if we instead use Pythagoras. So OA dot AB is equal to 3, 2, negative 1 dot 4, negative 5, 2. Now, if you're a child genius and you can just look at that and see that it equals 0, that's not going to keep any examiner happy because we want to see that you get what the dot product is. So it's going to be 12 minus 10 minus 2 equals 0. So you must show some kind of thinking. So that means we've shown that OA and OB are perpendicular. Now, let's look at the second part. Assuming that we completely haven't seen the Pythagoras way to do this, what are we going to do now? Well, we want to find the area of triangle OAB. Let's go back to our picture here. So the area of this triangle OAB, which is sitting in 3 dimensions, is going to be found with half the base times the height. So that's really easy because I've got a triangle with a perpendicular height already. So this is my height and this is my base. So I need to find the length of that line from AB, which is the magnitude of vector AB. And then I need to find the magnitude of OA. Right, so the magnitude of OA will be, what were my components? Let's see. So it'll be 3 squared plus 2 squared plus negative 1 squared, which gives me 9 plus 4 plus 1, which is root 14. So just leave it like that for now. Don't go rounding just yet. What about the magnitude of vector AB? Magnitude of vector AB is going to be 4 squared plus negative 5 squared plus 2 squared, which gives me 16 plus 25 plus 4. So that's the square root of 45. We could simplify that into 3 root 5. We don't have to. Okay, so the area is half base times height. So that's half root 14 times root 45. Now, when I take that, chuck that in my calculator, I think we get 12.5. And remember, we have to round to 3 significant figures for Cambridge, unless we're doing angles. So you get told all that stuff on the cover sheet. Or you could leave it as an exact value. So I just want to chuck this in here because we're going to spend a bit of time working with surds this year. So we can combine the 14 and the 45. I know that you're going to grab your calculator, but if you think back to primary school, some of those numeracy strategies were really good. We can rewrite this as, instead of 14 times 45, rewrite it as 7 times 90. And then we can think of that as 9 times 70. Now, I'm not suggesting you do all this in the exam, but it just shows you how we can think about surds a bit better. So then that's my final answer, right? So the area, if I don't want to go with the 12.5 approximate answer, can be written more beautifully as 3 over 2 root 70, and it's units squared. Okay, so if you're still watching, congratulations. I'm going to do the Pythagoras way now because I think it's pretty cool. So we're going to go back to this bit here and show that angle OAB is a right angle. If we use the Pythagoras method, we're going to do a whole lot of the work for the second part in here. So what we can say is that if a squared plus b squared equals c squared, then OA and AB must be perpendicular by Pythagoras. So let's get on with it and see if that's right. Now I'm going to do all of this again. So OA, I'll just pause it. Okay, so we've got those magnitudes, and now we'll find OB, so set those all up first. So that's the same as what we did before. Oh, actually, we didn't do OB before, did we? So it's going to be 7 squared plus -3 squared plus 1 squared, and that gives me the square root of 59. So you can already see these numbers adding up to the right things, but it's not enough just to circle them. That's just mucky. So we've got to now show, logically, what are we doing? So now we say OA squared plus the magnitude of AB squared is equal to 14 plus 45, which equals 59, which is the same as OB squared. Never sure if I need to put those little straight lines on, but I will. Okay, as required. So there we go. That's the other way to show that the two things are perpendicular. Thanks for watching, and thank you for the people who said that they liked the first one. That's why I'm doing a second one. So if you guys watch these videos, then I'll make more. But if they're not working, then I won't. So let me know what other topics you'd like revised, and I can do some on those.